Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter, and last time we spent time cleaning up the error handling in the interpreter part of the program. Today we're going to go back and handle things in the parser, make some decisions, and see if we can just improve the way all that works. All right. Well. Can't seem to get out. That'll do it. Okay. My escape key didn't escape. All right. We'll just take a walk through and see what's going on. So the way we are now, we have these. We have an enum that handles all the parse errors, and there are a bunch. Some of them overlap a little. I think we could probably do something there. We have an array of error messages and a mechanism to get to it. Is our interpreter using errors? Interestingly, no. Okay, well, that's something. All right. So the basics of the parser is it's a recursive descent parser. So you have this, basically you keep the next token ready to go. And so to start the parser, you start with an initial prime the pump kind of thing, get one token ready, and then you can look at that. You've got one token look ahead, basically. There's a few places that maybe are a little funny on that, but in general, that's what happens. And you match something and you call next token. So some cases we have this require helper that if we're expecting exactly one kind of token, we can require it and throw an error otherwise. All right, so parse, it starts at the top as single line because we're not doing whole programs with basic. The interpreter is working a line at a time. We could walk through them all in order if we wanted to, but basically the input string is one line. Okay, and then at the top level here, we catch any error messages and append them to the error messages list. Let's see. Why is that as parser error? Oh, because I was lazy and they're probably not necessarily parser errors, right? Yeah. Okay. So there's one thing. I guess I could start a list. Okay. I don't know. Call me crazy, but usually I do plus signs on my second level. Okay. We generate this dot error. So if there are any messages, we return an error as our parse. Let's find parse. Okay. So normally parses are things like lines and so on. In this case, we just return an error. So we hope our interpreter handles the error. Let's see. So that's, interpreter. Well, we know it does because the way Swift works, but somewhere we have to be explicitly saying dot error. There's a top level. There we go. Okay, so all we do if we try to execute that is we print the message. I don't think we want to do that. I think that's yeah. I think we already try and get around errors in our top level loop. Let's see, the run loop here. We parse. If we get any error messages, we break out of the loop. So we're not going to execute it anyway. So that's a waste. Okay. Now, all right, so we enforce semantics. If the semantics don't work, that's that. All right, another thing I don't like is I don't know when I have an error. I would like to know the line number and really the column number. Now there's some complication in the column number because one of the things we do, let's see, it's normalize. Is that in here? No. Maybe it's in program. Oh, it's in Lexer. Yeah. Okay. So, one of the first things we do when we're going to process a program is we basically squeeze out all the spaces and capitalize it. If it's a string, we don't. Okay, but for a regular piece of code, we do. Okay, so here you can see a string piece, replace space with nothing, and uppercase it. All right, let's fix that formatting a little. Okay, otherwise, and I don't know, sometimes it helps to format these like this. Otherwise, we just put the quoted piece back in, basically. So we split on quotes and reassemble it with the pieces either uppercased or just put back in. But what that means is that very early on, nobody knows what column it started in. Okay, so we will have to, well, have to is strong. We're going to have to, if we're going to report the column, it would be nice to report the column the user sees, and yet we don't know the column the user sees because by the time we parse it, it's been squeezed out. So one option would be to somehow track where the squeezing was and kind of work your way back to the user's version of the column. Or I don't think it would be impossibly ugly to say, here's the normalized line, and let's show you the position in the normalized line, and you work it out to the corresponding position in your line. It's a little ugly, but I think we've lost the column numbers, and maybe that's a flaw we don't want to live with. I don't know. Because the thing is, in BASIC, if you say, let's say you got a for next loop, FO space R, the word for, it should still find the word for there. It should ignore spaces even in the middle of tokens. And yeah, but we simplified things. Maybe it's not so bad now. If we said while space or number, let's look at number. And here we are a level in already, but you repeat 0 through 9. We could skip spaces at that point as well. If we did that, yeah, this has to be reworked a little. And then same kind of thing in variables. We look for I don't know what this is. Handle to variable. Let's see. A to Z is handle variable. Okay, so we know we have a single letter. We skip the index. it may be followed by an optional digit and maybe followed by an optional $sign. Again, I think we could probably work it out to skip is digit or space, and then I don't know. It's awkward because Basic really wants to say just squeeze it out and be done with it. But strings don't need to ignore spaces. It's only 2 cases. Maybe we'll do that. Okay. So more to do. Yeah. Should Lexer just handle spaces without normalization? All right, back to the parser. Okay, so here we are returning error. Let's see if anybody else returns error. I don't think they will. Whoops. Find error. No, that's the only place that does. And the error messages are appended there. Now, the other thing with the error messages, like this situation, I believe I can convince myself that error messages can only have one thing in it at a time. All right, so let's find the references to error messages. Okay, interpreter looks at error messages count for each error messages append. That's the only call, right? And that's the top level line. If you try line and you get an error message, then you're going to write an error message in there. Okay, and the tests make sure about it. So okay, so error messages is really not anything. Okay. All right. Now the next thing. Okay, so something going on here. All right, let's make a note. There can only be one error message per line. Okay. Parser. All right. Now in here, the mechanism is throw errors corresponding to kind of the semantics. All right. Line numbers have to be within the range 0 to max line number. All right. Okay. We require the line to end with an end of line. Okay. In the end, we return a parse, okay, with line number and the statement. And if you didn't have a line number, we'll skip over that token you gave us and we'll return a parse error, no line number. Okay. All right. And then we have a bunch of kind of a high level switch for any kinds of tokens. End token says there's an end statement. It's kind of like each statement type, basically. I'm going to add a little more space just to open this up a little. Okay. Another thing going through my head is like, is there advantage to me to have all these independent errors? And I kind of think maybe not. You know, if I just had one kind of error and that because if I have 87 kinds, right, then somebody has to translate this, and so somewhere there's a big table or switch statement or something that's going to know, hey, for unknown statement you should print unknown statement. All right. So let's add that. Okay. And what are, at least this approach so far, we're using throws. So we added that to the interpreter to use throws just as a normal kind of mechanism. So the result is if something is valid, hey Rick, how are you? If something is valid, then we return a parse, okay, and it knows it's a parse. If it's invalid, we throw an error. That's a good. We look to be using that consistently. All right. Yes. Define. That's a complicated one, isn't it? Require float types. Require matching types. Good. Expressions. Now this is. There's a duplication across these things. Maybe that's okay. But we have a level for every precedence level in our thing, and they all kind of look the same. It's a while loop. You do something, and then you have a while loop for when you can do more of it, and then you repeat it. But there's a little semantics in here that maybe is different. Well, all these numeric ones, they require a float type. That's probably true. But still, there's similarity across them. I don't know. We'll have to decide. Okay. Now the bottom level of the expressions is factor, which is parenthesized, numbers, and yeah, I guess that's okay. Strings, variables, predefined function tokens, and otherwise error. Okay. Yeah, everything's pretty consistent. All right, that's good. Is parameters equal argument type? Oh, handling arg optionals. Yep. Okay. Use defined functions. There's some similarity there. We've got left parenthesis expression, right parenthesis. User defined functions only take one thing. Okay. The dim left parent series of commas and right paren. That pattern is there elsewhere too. Where was parenthesized? Variable. Yeah, again, if you have subscripts, right, it's left paren, commas, and then append all that, and a right paren. I don't know. There's similarity across the parts of the grammar, and maybe we could do some work there, but mostly I want to focus on the error handling today. Okay, and I think, well, let's look at the totality. Parse, single line. It always returns a parse. Error messages. See, I think, all right. Let's take this. Okay, handle parser errors better. How does the interpreter access them? Well, right now it accesses them directly and does its stuff. Okay. Should parser generate .error, make errors report line and column number? Should Lexer just handle spaces without normalization? there can only be one error message per line. Do we want so many independent errors? Okay, so I think what I think might be a better strategy is maybe we keep this error, because then everything is very symmetric, that it's a parse, and the interpreter doesn't have to mess with this stuff. It can do that when it handles the error case. Okay, so make it do the work. All these things don't know the line number. Interestingly, I mean, we don't track it, and maybe that's a state that we should track, for reporting errors. Okay, and often where it happens, the Lexer may do that. You push the column, keeping track of the lines and columns into the Lexer, and maybe make your token record that. Okay. All right. So I think what I want to do then is I want to keep this notion of errors, but I'm going to return a parser error instead. So I'm just going to return the error in here. And then parser error it'll be public enough for the interpreter to see it. Okay, so error, we had parse open a minute ago. I think I lost it. Okay, let's go in there. All right, error substring. Well, I think this is going to be an error subparse error. And that tells me this probably parse error belongs over there. Okay, is that going to run? I got my keystroke thing turned back on. That's a little something. Okay, so all we've done so far, maybe some spacing, but we've moved the errors messages over there. So we'll see if that's a problem. That slow first test run. All right, but what I think I'll do then is we don't need error messages anymore. The error messages. Okay, good. Move parser error to parse. Swift. No, everything's slow. Okay, here we go. Let's see. Move the. I want to put the error in the error token. Okay, so here I would like this token to be a parse error instead of a string. And I don't think it's in that many places, so I'm going to change it and build it. Yeah, it should. Well, I'm surprised it. Okay, there we go. Enum case in a public enum uses internal type. Okay, so I got to make this public. But there's more to it than that. Yeah. Okay, so when we record it, well, let's put the error in. And I'm going to borrow that same code. We'll address that later. Okay. We'll do it this way. Okay. All right. And then, okay. Where is that? All right. So now I'm going to say the interpreter, if it sees an error, it's going to stop. All right. There's no point in anything going beyond that. And I'll say let error, my fancy keystroke, error. Okay. Now, this is a non-change in a sense because our loop will never get here. If there's an error message, it breaks out and it never looks at done again. It just returns whatever output it had. Okay, so that's irrelevant at this point. Okay, now, sorry, parser. I don't know if, do I have to? Not exhaustive. Is keyword. Oh, we do it like that? That's weird. I thought I would do that. All right, I'm gonna have to look. Swift do catch. I just want to say catch with a. Oh, so I put the case in. Okay. Okay, this is not what I thought it would be. Huh. Not exhaustive. Okay. Now, I never throw anything but a parser, so I don't really think I'm going to have a problem there. All right, but let's get rid of error messages. Well, let's stop using it first. Okay, so up here, I'm going to take this piece out. Okay, so I get the parse. Now it could be an error, and we'll see what happens. This may change. Some tests may break. Okay, so that statement makes me say, run our test, check in what we got, and then go from there. Okay, and I've forgotten the exact change we left in place. Okay, the interpreter quits on error, and that's okay. Yeah. Make the interpreter quit on error and return parse.error with the error rather than a string. Okay. Now my claim is if I do this, I would get, well, this says plus a new line. All right. So my claim is if you get an error, we could only have one before, and it would append output to, or that to output. Okay, so let's try returning that. I guess that's output plus equals. Output is try step of output. Okay, I don't like the way output's handled, but I got to match what's going on here. All right, I think this should be at least close to a non-change. Okay, good. So we make the interpreter use .error rather than checking for parse errors. All right, now this is totally dead. Nobody's looking at the parser errors now. Well, there's a test, but I think we can delete it and adjust the test. Okay, and who else? And this method's not called by normal code anyway. All right, we'll see. There may be a test or two that's, well, we know there's at least a couple tests that are looking. All right. Let's get the value, and that's a parse error. Okay, so let output equal that, and now I think we want to assert that output is expected new line. Okay. Assert result is expected. Well, expected is not going to be correct if it's not. Okay, so we don't need that. Oh, output parse. Output. Oh, this should then be dot error of expected, I think. Output is a parse. Okay. Result, no longer we don't have error messages on the side anymore. All right. Okay. So the way I think of this is we're using two mechanisms then. The bulk of the parser is using the throw statement when it finds an error, and then we're changing that error into into sort of a return value. And we've extended our type with this error case, and it makes it simpler for the interpreter. I think it's an improvement. Okay. Let's make sure everything's running. What I just changed. and we'll check that in. Whoops. How about commit? Okay, so remove now unused error messages. Okay, so let's see what our to-do. We've got this. Well, let's change this to no positive statement. Make interpreter access we decided the answer was yes. Line and column number we haven't addressed. Lexer, there can only be one message per line. And then, do we want so many independent errors? That's a good question. I don't think it's helping anything. All right, so I think what we'll do, I want to cut down our errors and just return a generic one, kind of like we did in the interpreter, and almost the same. Right, we just had one. What was that case? Oh, we had can't happen an error. I think I just want to have error. And we don't have line numbers yet, so I won't worry about that. But I think let's add a case here. Case error, and it's going to take a string. All right, now nobody uses that, and we don't have a case statement that goes across this type, so should be neutral. All right, now I think I'm just going to migrate these things, and everywhere that's calling throw, I'm gonna turn it into text. Okay, so I'm just going to have an error message text. I don't know if I should separate that. All right, let's can we do this in an easy way? I think we can. I think there's a way. There's an enum. So I've got my enum for my cases. I think I can make an enum for the strings as well. So let's say parse message. And then I think I just assign them. All right, I don't know where that happens, but I think I can do this. I can say equals unknown, unrecognized statement. All right, does this build? No. Cannot have a raw value. If I make this of type string, everybody else should complain. does not conform to raw representative. No, I really don't want to. Swift enum with associated values. That's what I want. Cannot be a type string. Okay. Ugh. No, it's not quite what I want to do. Let's find the documentation. Swift switch. Why did I say switch? I want enum. Is it developer.apple.com? I don't know if I just get in there. Let's see if this just gets me close enough. I want the Swift language more than. Language Swift. I think I'm just getting the library. Okay, maybe try this. Swift switch statement. Blog. No. Language guide. It's so weird. This is not searchable. Okay. I know there's a way to assign to these things. Associated values. That's not quite what I want. I like them. This is what I want. Raw values. Case this equals that. Character. Int. String. Is that not what I was doing? Well, I didn't do it here for sure. Maybe I have to do all of them to make this work. Apparently. Okay, but but it can work. Okay. Um, is that going to be better? Well, my thought was I would pass parse message. But then I'd have to do like raw value. Well, yeah, that's kind of nice. Um, what's a good way to get these in there? Yeah, this is more of a can't happen kind of thing. But, all right, let's deal with that case. So if I threw parser dot error, dot internal error, can I do that? I got to do that. Okay. Let's try another one. Argument count mismatch. And adding that up here. Okay. Argument count mismatch. Which is really more like all right. Is that going to build? No. Wow, this is parse message. Type string has no member. Yeah, I don't know if this is really looking good. Build. Yeah. No, that's too much work. If I had to change them, how would I do it? Well, they're all in one file. Maybe I'm just talking myself out of it. All right, let's take this out. Okay. function requires a parameter. User defined function call. We got the name. Okay. This is the dimension size. Okay, we'll save this one. Okay. And maybe I've done enough. If it builds. Okay, let's run some tests because some of these tests may be relying on particular text or things like that. Yeah. Let's see what checker wants now. Wants a parse error. Okay. I know we're making our tests a little more dependent on these strings. Maybe we missed a type mismatch. so we convert some errors to use .error instead of a specific error. All right, let's go back here. Start at the top and look for throw. No, that's a little different. I think that'll make sense in the context. All right, and parser. Okay. Keep looking for throw. Sorry, it's really if an X. And this one is def function name is followed by extra letters. Okay. That should be enough to get us some. Oops, error. This really should say maybe cannot be. Okay, run tests again, should pass. Failure. Okay. I'm gonna look for throw space. Okay. Expected start of expression. Okay, yeah, now we got to deal with these requires. Well, let's make sure this is good. Okay. I think that's probably what we have. Okay. I'm trying to differentiate between the errors and how they're printed. So the ones that have it in quotes, I don't know. That's this is better to me than the previous one. The previous one was looking, how am I going to format this string? If I only have it in one place, then it's not so bad. But I don't want to test the formatting every time. I'd rather test the error. Okay. And the last test, well, it's this thing. I don't really want the error. I just want the message to be a string. And I'll put it in the error for you. All right, we should get some complaints. Oh, there's a way to get to the next error. Quote, command tick. I think that's sort of the same thing. I'm going to find all these left paren ones first. Okay, hopefully that runs. Should have some errors. Not too bad, hope. Check error. Oh, D is an error. Assignment is missing its equal sign. Does this work? Not really. All right, there's one at the bottom. Okay. Whoa. How did that happen? Oh, did I just bump a breakpoint? Let's do that again. Still failures, okay. Missing right parenthesis in an expression. That almost sounds like I got a bad left parenthesis somewhere. So factor left paren, let's check out this one. Require right paren missing. Let's find all the right parens. Oh dear. Nothing like a global search and replace. Okay. That's why we have tests. Apparently. Oh. Can't type. def requires equal after parameter definition. Okay, handle remaining errors. Okay, we're overdue for a break, so let's take a break. But when we come back, I think we get to delete these 30-something lines, 20-something lines. Okay, so we'll take like 3 minutes, grab a drink, whatever, and go from there. See you then. Hey, welcome back. All right, let's see. So my hope is all these can be deleted. And let's see if everything still works. All right. So what we've done is we've taken everything down to a single error type, and now the interpreter sees, well, it sees that type. Let's find that switch statement again. Okay, so it sees an error, and this really is the message. I thought we renamed that already. Maybe it was in the, oops, other type, I guess. Okay. And that should, yeah, that should put the message at the end of the output. And it says done is true, so we'll leave the loop after this and return that. Okay. Make sure it's running. And we'll check that in. Delete unused error messages. I think it's now unused. It's probably fair. All right. Do we want to do that? Do we want to do that? Do we want so many independent parser errors? The answer is no. All right. So this line and column number. Can we make the lexer handle spaces without normalization? Oh, you know, it's not as simple as I thought. Because all these things, we just look for the prefix and expect that stuff. So I don't think that's going to be so easy, because if you had A space BS, it's supposed to find apps. And the way we do it, yeah, because we normalize first, then it's fine. Now, the other thing I could see is, well, okay, different ways we could do it. One is we could go back to what we did. No. I'm trying to think if the start of each token is going to be, I mean, we're going to skip any spaces. We see an A. And if you saw A space BS, yeah, it's like, I'm wondering, could you normalize it before you do this matching? And I guess maybe so. We're not going to match left quote or double quotes, so strings are not handled through this mechanism. Okay. Oh, I just don't know. Okay, another way to do it is to map back. It complicates the normalization. Let's find normalize. Okay, normalization right now, it takes a string and it returns a string. What the mapping would be to find the index of those original streams. It would be a different approach, basically, but as we gathered, we would keep track of the start of spaces, because what we would have anyway. And I don't know if I want to pursue this today. It's needs a fresh mind. But if you had A space BS minus 3 less than equal 7. Okay. It's an if, so the start. IFABS. Okay. This is legal. Okay. If you squeezed out the spaces, it would say if abs minus 3. Okay. And our prefix would say, oh, there's if, there's abs. Okay. But what we'd have to do to offset it is kind of like find every position in the normalized. Basically, I'd want a map of every position in the normalized string to the column number in the original string. And I don't know, that doesn't sound so horrible. Let's see who calls normalize. Okay. Called once, right? So there's nothing. This thing could return a map and a string, and nobody would be feeling bad, I guess. Okay. And then the error would report. It would know the position in the normalized string, and the map would tell us what's the position in the real string. Okay. So, that's not impossible. And what we would like to do then is attach the position to the token. Let's see, where's our tokens? We haven't had those open in a while. There's so many tokens. That would mean each token has these things. I would probably not. I don't know. I'd probably want to make a struct that has this token type or something like that, and then pass the line number and the column number in that structure. Okay, and that's actually a pretty common way of doing it. Okay. We would break a lot of stuff, though. What would we break? Let's find this. Okay, token. Find prefix token. Well, what would break would be the parser. Everywhere that looks at token, well, maybe not. I mean, everybody goes through next token. We could call token that thing and then rename it maybe token type. It might be all right. Let's find the word token, capital T. Lots of next token. Token equals unknown. Relops. Next token. Token. It's a moderately big change. No lying about that. What we can do is we can separate these two issues. The position, we could just report the normalized position for now, and that would let us get the type stuff straightened out. Right. Okay. Yeah, there's a little complexity. All right, but okay, let's see. Parser, sorry, Lexer. All right, I want to make a one step. What's a small step? Well, let's rename this to token type. Come on, Xcode, you can do it. There we go. Okay, token type. Okay. And now my Lexer. Trying to see anybody who looks a little different. Okay, this is token type. Okay. All right, let's see if this rename worked. Lots of files touched there. All right. So what I'm going to do then is get these token types straightened out, and then make a token that is a struct. Okay, let's go ahead and do that. Well, no, let's check in the rename. Okay, and I want to make, can I declare it first? Can I say struct token? Oh man, I hardly. Do I even use structs? Well, that's clearly a lie. Without filters. Yeah. whatever of type. I guess that's all it needs. Okay, that's the kind of thing we want to have in here. The attached stuff is tied to the token type, which is usually what we're manipulating. Okay, so this type, let's see. So I want a type that returns a token. So I'm going to call it next, returns token, question mark, yeah, token, and oops, it calls this for now next to returning token type. Okay. Type is next to, let's see. Okay. That. Now, my callers, they switched to saying they wanted token types, but I want them calling token instead. All right, so parser. Now, most of them, okay. Let's do, let the token equal lexer.next. How is that an exclamation point? Type of expression. Okay, so here I'm saying peel this apart. Oh, the token. What type do you think you are? He's a token. I thought you could do it this way. Maybe you can't. I think maybe I'm going to have to say field by field. Yeah, that's not a problem. Token equals the token type. Okay, I'm getting what I had before. Next token. All right, this should be the same. Type Lexer does not conform to iteration protocol. I don't know what it's adding. Why is Lexer? Why isn't it a sequence of tokens? Function next goes to token optional. Can I say sequence of token? I don't think I do. Yeah, you can't specialize that. Okay. Lexer does not conform to iterator protocol. Oh, this is not right now. Okay. Token. These, I think I want to get to type. I think it's only the tests that have to adjust. I think because we changed the interface. The code seems like it's okay, built anyway. All right, let's see how this does. Oh, they're optional. Eugh. guess I gotta do it in here. Okay, I'm kind of questioning this. What if I take this off? I'm curious if he builds. Build failed. But is that's all in the tests, right? Okay. I don't think it ever returns nil. Yeah, it never does. If it's not nil, it's that. Is number, can this return nil? No. Okay, I don't know. I don't want to juggle too much, but I think this always returns a token type, even if it's error. Now, you may not like that, but I don't think it's wrong. Token type. This one is possible to return nil. Okay. And a variable always returns a token type. Okay. And a little bit. Okay. Where's my next? Next never returns a nil. Okay. Now the callers may be expecting a possibility of a nil. So let's build this. If the test for these lecture tests, I'll deal with them in a minute. Probably the ones I quote fixed are problematic. Okay. Lecture does not conform to iteration protocol. I don't know if I care. I think there might be one place that loops across them for some reason, but yeah, I should be building. Right, next token, this now says it's always there. That I think is just not caught up to the build. Okay, some of them we've quote fixed. They're going to break again, but build succeeded. Let's try that again. Well, Lexer.next should only return real tokens, so that's okay. These, that's a legit complaint. Now, why it's not complaining, I'm not sure. Okay, let's try running. Okay, good. Okay, here we go. Okay, make Lexer produce struct token instead of just token type. Make parser. Well, adjust parser to match. Okay. Back to the Lexer. So let's inline that next thing. I don't think anybody's calling next to because we just created it. So, well, that's all a bunch of stuff. Well, we can rename it to get token. Next token type. And that gets wrapped here. In the end, we'll maybe change that too. But okay. Wow. Let's go back to our to-do. Make errors report. Should Lexer handle spaces without normalization? All right, Lexer. We don't really identify the line number at any point. At one point, we were doing something that kind of did, and then we said, well, let's just parse integers and treat them as integers instead of trying to pretend we knew which places could be line numbers. And in our factor, we adjust for that. So let's find parser, and let's find factor. Okay. So we can get numbers or integers. If we get an integer, we wrap it into a float, and the rest of the code can rely on it being a float at that point in the expression. Because there's several places you can have line numbers that are valid integers, and we just want to make that all flow together. We did dim, and that wants integer sizes. And we will do go to onX go to, which wants a series of line numbers. So I guess what would be a test? I think the test would be if I get a token, right? Let's see. If I get a token, it should know its line, and all tokens from that stream should be on the same line because we're doing a line at a time. All right, so where's our new line case? I think we need to do a little extra handling at the end of a line. Well, no, we don't, because we just return end of line. Okay. I think at the beginning of the line, let's make an adjustment there. So, what's the test? I think the test is something like, let's just do a simple line input and check that it knows the line number. Let's check token. Well, we want something a little fancier. Okay, the program is 10 print. Token line number should be 10. And if we do it should also be 10. We just said line. Just to emphasize that a little bit. Okay. This test should fail. It should come back with 2 zeros. All right, 0 not equal to 10. Okay, let's take another break, just a couple minutes, and we'll come back and try and get these line numbers in. Hey, welcome back. Alrighty, so we got this token thing. Basically, we're going to give our program some context, some state. All right, this is all information. Okay, let's track that line number. Okay, so it's a var line number. Type is, well, I guess I think it's going to be an integer. We'll start it at 0. I don't think it's a terrible convention that line 0 means there's no defined thing. We could make it an optional int. But I think we need to know maybe maybe optional is the right way to model this. Okay, and we'll start off equal nil. So when you come in, well, let's assign it in there just to be explicit. Line number equals nil. Okay, and well, whatever matches the integer, maybe even just a number. Okay, let's change this. If is float, then we'll do something else. We'll do something else. If it is float, we're going to return this. If it's not float, we're going to return this. Okay. But if it's an integer, let int value equal int of value, bang. And if our line number, if line number is nil, then we want to save it. So in effect, we're saving the first integer on the line. I don't know if that's, well, okay. If you say print 10 as your whole line, we're going to say the line number is 10. That's a little weird. Let's see if our test passed. That'd be a good thing first. Oh, no, they don't, because we didn't assign the line number. Sorry. We've got line number. Oh, I just don't know if the 0 thing is the right way. It seems complicated to have to ask. I mean, that's one way. Well, let's do this for now. Let's just pass the test, right? Oh, all of them. Okay, I guess that might be better. Okay, so let's do one without anything. Okay, and this should pass. Okay, we forced it there. So I don't know that that's really, that optional thing is helping anything. Well, it's helping something. It's helping that if you didn't have a line, let's see. Trying to think of a situation where you got. All right, so if we said that line 0, if somebody said 0, print 10, okay, the line number token would be there as an integer, and we would take it as a 0 and set the line number to 0. I guess that would be accurate. The tricky one then is like print 10. The 10, it's picking up the first number on the line, which is not unbearable. I mean, it definitely gets caught. Maybe it's okay. I mean, yeah. All right. I think we're kind of okay. it's just a weird situation. Maybe I just should document it. Okay, if they forgot a line number, print 10, and then that's just token now. Oh no, maybe it's not. Token 1, the line is 0 because we just haven't seen anything. And token 2, we say, oh, the line must be 10. Okay, I think that's probably accurate. Okay, I think this is, I'm documenting something that's a little weird. It's probably not a problem. I mean, like with our REPL, it knows it's a line of code if it starts with a digit. Well, if it doesn't start with a digit, it tries to interpret it as a command, and it's going to say, like, I don't know how to print by itself. So in the context of our whole system, I don't think this is a problem. Okay. Now the column number. This is more controlled by the start of the token. I mean, we got index equals 0 to start with. Okay. And so I think at the start of each next I think we need a column. Column of int, and let's start that at 0 as well. Okay, and in our return, let's return that column. I think I should have already checked in. Hey, am I running all my tests? Okay, good. Let's see. So we make token stream produce line number with token and column defaulted to 0. Okay. All right, another test. Token line number, default line number. Okay, let's do some column work. Token column is tracked. Let's go back to this. So I want to say token.column is 0. When we report them, no, I guess we're going to be 0 based. So 0 is column, is the 1, 1, 2, 3 is P. Okay. And yeah. Oh, it's 2. Haha. So really, it's tracked against the normalized line. Okay. 0, 1, 2. Okay. And this is going to fail because it always returns 0. And maybe it wouldn't hurt to do 10. Oops, column. Maybe we should do another value too. Okay, 0, 1, 2, 3, 4, 5, 6, 7. If I counted right. Okay, always 0. So that's there. Okay, good. All right. So I think at the start, well, start here, that's fine. At the start of the next token, I think we really want to capture it here. Okay, so index and then column down here. So at the start of the token, we are looking for, we start with index at the starting character of the token. Excuse me. So index is 0, and it captures that there and then increments. Index gets incremented, but when you come back in for the next token, the thing at token subindex is what you're looking for, I believe. So let's run this again. See if it just runs the 1. I'm curious. No, but that's okay. All right. Commit that. So we track the column number. It's weird. I thought the parser stuff would go a lot faster and this would be a little slower, but I think we're okay. All right. And then in our to-do terms, handle parser errors better. Should Lexer handle spaces without normalization? Well, that's a good question. Make errors report column and line number. Well, I guess we're sort of doing this. Make tokens no line and column number. And let's put that down here. Okay. And I think we've done that. So now let's do this. Errors report line and column number. Okay, so the parser I guess it's the errors, right? That ought to be doing this. Okay, so I'm gonna, what are we gonna do? Well, let's find, what's an error? We gotta find an error. Okay, right paren missing. So I would really like the throw statement to deal with this. Right, let's do definition. Yes, I want error, parse error, to include line and column. Okay. And then somebody can print the error and show the line number and the column number and stuff like that. Okay. But what I think is going on, we've got too many places that throw. This is fine. Require needs to know. But I think all these other throws, I think we should extract a method to do the work. All right. And then I think, well, this is kind of primitive, but let's do it this way. Oops. Oh, you don't want to extract a variable for me? Oh, that's terrible. No. I just don't know when this refactoring tool knows what to do. I guess this one it might do. No. What about this? That it's okay with. Is my escape key not working? Okay. Well, let's make, I'm just going to put it in here for now. So function report error takes a string, takes a message of type string, and it throws, and that's really all it does. All right, and it's going to do this. Okay. And we'll call it here. Report error. Okay. And let's move this up next to the other one, next to require. And I don't think it hurts to say file private here either. All right. This should just pass. Build failed. There we go. Oh. I guess I gotta do that. Okay, but I think this text, well, let's do a replace. I think maybe my Xcode is getting flaky here. Find, replace. How about find? Oh, how weird. Okay, well, that goes to that. Find throw space. I just don't want to reboot with 10 minutes left, 5 minutes left. Probably should have done this when we were changing everything before. We'll fill that one in later. Oh, all these are unhappy, huh? I guess I can just return they're not. Results. Oh. Throws. I guess it's not able to detect that it really does throw. There's a bunch of these too. I mean, I can return something. Oh, this is a bummer. Well, what if I put one in? I could say return.error can't happen. And that's true enough. How annoying. This is really weird because usually you work really hard to, well, not really hard, but you usually it's very common to have a single error reporting mechanism, and yet this doesn't like that. All right, I am reverting this file. Okay. And in the moment I have left, I'm going to rename this file. Okay, and let's do a clean build. Okay, and so I think, well, we still need to make, hello, welcome. We still need to, we're just wrapping up though. We have tokens that contain lines and columns, and we want to make sure our parser tracks that through. Which I think we would like to add to the parse errors to make that happen. So we'll pick up there tomorrow. Let's see, we renamed token type.swift to token.swift. Okay. And make errors report line column number. So we'll need to pass those in. I don't think the easy way is just to put them in here off the token. Oh, 15 or 16. I don't know. Yeah. Yeah, I usually pick them up once they come out, but I don't want to fuss with the betas. I know I got to upgrade Xcode one of these days too, because they've added all the support for that. But anyway, with these errors, we need to get line number and column number in there. I'd hoped to make a method that could do the job, and apparently that's not easy or not going to happen. So I may have to just include them, and that's maybe we just track that when on next token. I don't think that's terrible, but I hate having to spread it around. So anyway, we'll pick up there next time. Next time is tomorrow, 10 a.m. Eastern to 12:30 p.m. Eastern, or 3 to 5:30 UTC. So hope I can catch you in the future. Yeah, there's a lot of stuff coming in. I mean, the stuff we're doing with this program doesn't have anything to do with any of that, though. It's it's not very visual, but yeah, there's some nice additions. I'm happy to see Swift UI start closing the gap with UI Kit a bit more. Maybe not quite all the way there, but that's a good thing. All right, well, thanks for joining me. Hope I can catch you in the future, and have a good evening. Bye bye.